All right, well, you guys got any questions from homework stuff that we've done? Yeah.
28.9.2.
Spoken like somebody who's tried a lot of things on that problem. Let's see. 28, the bane of my existence. Oh, yeah, okay. So when they say Gauss, Jordan, that's, of course, like taking it all the way down like we did in class. So they give you this here. Right? So then how do I write that in the right form so I can use Gauss-Jordan elimination, the row-reduced echelon form stuff? How do I write it?
1 plus 4 with a line next to it, and then a 1, and then 3, and -2.
Yes. All right. And this is a nice, what I would call 2x2 system equation to say. What size is the augmented matrix? 2x3. But hopefully everybody now. 2x2, and it's 2 equations, 2 variables. So I'm just going to say that craziness. The beautiful thing is you have a 1 here, right? I should probably do an example like I said I would last time about what if you don't have a 1. So what would the first step be? What did you try?
I tried multiplying the top by -3.
I love it, because then that would kill this, right?
Yeah.
So if you do -3 row 1 plus row 2, and where are you going to put the answer? What's the goal? 0 where? Yeah, well, no. You want 1, 0, 0, 1. Right? Yeah, so you're going to add -3 times this plus this and put the answer in row 2. Because that's where you want the 0. You don't want to lose the 1. Does it really, really matter mathematically, numerically? No, eventually it doesn't really matter, but I want to make it as easy as I can on myself and leave that there as it already is matching what I want, right? So I'm going to put the answer in row 2. So if you do -3 row 1, what would this become? -3, -12, -3. Then you add them together. What do you get?
0.
0. -14.
7.
7. You still got 1, 4, 1. Right? And then what can you do this row here? You don't have to make a 1 here yet if you don't want to, because you see how that's going to make a fraction show up over here. You can divide by 7. Leave this as -2, because then that really works nicely with that 4 that you want to kill. I mean, do you see how you, like I said before, you never have to bring fractions into it if the answer is fractions, is going to have to come out in the end. But you don't have to do it in the middle at all. Never. Okay. Is that enough to get you going? I mean, the next step I would do is divide this by 7. It makes a -2 here. How can you kill that 4? Well, you double it, add it together. Yeah. Same idea you used here. Exact same idea. Yeah.
So can we do another example if it wasn't 1?
Yeah. Let's do one. Guess I can't officially say another one because I haven't done one yet.
Mm-hmm.
Is that cool? Everybody has that?
Yeah.
Not cool? No? So what's up? What's the trouble? What do you get when you divide this row? Do you see why? I definitely want to divide. I could divide by -14 to make a 1 here, but see how that would make this a fraction. I don't need to do that to myself, really. But what can I divide by to make this next step easier? Yeah, divide by 7. So then what's that row become? 0 divided by 7. -14 divided by 7. negative 2. 7 divided by 7, 1. And see how these now, the exact same idea you used here, what are you going to do to this row so that it will kill this part? You want these to die now, or you want this one to die. So what are you going to multiply this by? Times 2. And then add it, same way we did the first step. For the same reason. Right? I mean, do you guys... It's sort of like synthetic. You bring it down. Multiply, add, multiply, add, multiply, add. So I can make it really long. It doesn't matter. You just keep doing the same thing over and over and over again. Yeah, I can make a big-ass matrix. It doesn't matter. You keep doing the same thing over and over. Kill, 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 kill. Make zeros, make zeros. All right, maybe. Maybe. Okay. All right. Anything else from homework before I do the example of a matrix without a 1 there to help you?
You just gotta get the hang of it. With matrix, you just gotta do it over and over and over again.
You just yeah, exactly. I mean, that's like anything. It's exactly like anything, right? Exactly like any part of math. You just got to do it until you get the idea. And at first, you don't buy into it because you're not used to it. You know, like, I like the other way. What was wrong with the way we did it before? Well, what's wrong with the way we did it before is I want a process that doesn't become exponentially difficult if I add one more equation on. It's like insane, right? 3 by 3 sucked by hand. Do you guys, anybody agree with me on that? It just does. It really just does. But can you imagine a 4 by 4, a 5 by 5, a 6 by 6? Holy shit. Every step you take is going to add a stupid amount of work on top. Matrices almost don't care. It's almost negligible the amount of work it adds. You got to make one more 0. Ooh. And I'm not trying to make you feel bad if you don't quite understand matrices yet. I'm just trying to show you why you want to understand them. It makes this kind of thing really quick and easy. All right, so let's do an example. Oh, yes.
Can you do 3 by 4 system equation?
Who do I? Oh, do a 3 by 4. Okay. All right, let's do one that doesn't have a 1 in it so I can combine a couple of requests here. Do they have one in there? Yes, they do. Beautiful. Perfect. Come on, 3. Come on, 7. Okay. So I'm gonna show you several things on this problem, just to start teasing some shortcuts and some other things to look for, some things you didn't even know you were allowed to do, stuff like that, right? The less comfortable you are, the more you just stick to buy the book. First column, second column, third column, bam, around. But I got to show you a couple things. If you do that, what sucks about the first column? There's no 1. There's no leading 1. Oh, shit. And this problem is not a big deal, though. Even any problem I give you is really not that big of a deal. You either just, like if you wanted to kill this one, you multiply this by 2 and this by negative 3. Do you guys see what I'm saying? You could just do that. Or I could make a 1. How could I make a 1? Well, first of all, let's write the matrix. What was the matrix? It's just going to pull off all the coefficients. Oh, Jeff, you're supposed to get new markers. Oh, shit. Hold on. I'll have this squeaky-ass markers. So there's several things you could do. Hopefully somebody notices you could start here. There's a 1 there. It really doesn't matter which column you start with, right? So that's one thing you can do is you can multiply this by 3, this row by 3 and add it here, multiply by negative 2, add it here. Right? Do you guys, let me stop there for a second. You understand that piece right there? Again, it doesn't matter. You don't have to start in the first column. I know what my goal is. My goal is this. And numbers, blah, blah, right? That's my goal. So it doesn't really matter which column you start in. Just if you pick a column, start there, finish it, move to another column. Finish it, move to another column, right? Okay, I like it. I like it. Let's see. So many faces are like, where's everybody else? I should have been with them. So I could start with this column and attack it like normal, right? And then just see how it comes out. I could do, like I said, multiply this by -2, multiply this by 3. That would kill each other, right? But I kind of want to make a 1. So can anybody see a nice way to make a 1? See, all I want to do right now is make a 1. And I could divide by 3. Dear God, I'm not going to do that. Shit, I don't want to deal with 29 thirds. You know? And then try to add it as I'm doing everything else. No.
But multiplied by negative.
Multiply number 2 by -1.
And then,
Use 1 and 2.
yes, okay, cool. Right? Subtract row 2 from row 1. Now that all it's going to do is make a 1. It's not going to make any zeros. It's just going to make a 1 there, and then I can use the 1 to kill the 2 and the 5. Right? Do you guys start to see what I'm saying? If you want to, right? Again, you don't have to get 1s right away. Just at the end, if it's not a 1, you're going to divide by whatever it is and make a 1 at the very end. Right? If at the very end you end up with 7, 0, 0, 5. Well, divide by 7, 1, 0, 0, 5 7. So the answer is going to be fraction, but you didn't make a fraction show up until the end, so who cares? You're done. You just say that's the answer, right? You don't have to work with them. Oh, man. So remember what I said. The most important thing is zeros. And the easiest way to make zeros is 1s, but 1s are not important until the end. So if you wanted to make a 1, I could take row 1 minus row 2 and put the answer in row 1. So that would be 3 minus 2 is 1, -2 minus 3 is -5, 4 minus -7 is 11, and 29 minus -14 is 53. Now I've made a 1, and then I can use that 1 to kill the 2, to kill the 5. Maybe. Let me say one more thing also. At least one more thing. What do you get when you add all 3 rows together? What happens? Anybody notice something? When you just add all 3 rows together. What happens to the middle? Cancels. Hey, so that's another thing you can do. You can add more than 1 row. Of course you can. You can add more than 1 number. You can say 7 plus 5 plus 4. Ooh. So of course you can add more than 1 equation. More than 2, right? Equations at a time. If you just happen to notice that, that's a nice way to make a 0 in the middle real quick, right? Keep that 1, make one of these guys a 0. Okay, maybe. If you don't like that, you never have to do it. I'm just throwing it out there. If you kind of get some of this stuff, I want to show you some other things you can look for. Yeah.
What if one of the equations is a square?
Oh, well, that's systems of nonlinear equations, which is not something we're going to deal with. That'll be a pre-calculus thing.
Well, I'm saying if it was a square and it's asking for a matrix, how would you...
Well, you'd have to have squared, squared, squared. I mean, to use a matrix,
Well, what if only one of the equations is squared?
then you'd have to have an x column, a y column, a z column, and an x squared column.
Oh,
Then you'd officially have 4 variables, x squared and x being 2 different ones for this.
equation.
And so you'd have to have 4 columns and then an augmented. Yeah. Okay.
All right.
I love you guys. To me, it's like shit.
Is there any time when like the equations are factorable and you have to have it like outside the matrix, the common factor?
Yeah, sort of. Not really. No.
All
No.
right.
Your comment sort of leads to there's a whole lot of other stuff you can do with matrices. Matrices exist on their own. They don't have to represent systems of equations. They do not. That's not the only place they come from. They exist on their own. There's a whole, there's a so-called linear algebra. And all they do is study the properties of matrices. And you're all like, for like a whole semester, yes. So there's a lot of other shit that we're not even getting into right now, right? But this is cool. Some of you guys maybe never even seen matrices before. You're just getting a little intro. I'm not going to go all through them. That'd be a little crazy. Right now we're using the most immediate usefulness is solving equations, systems of equations. I don't know, if I keep going with this way of doing it, What would be my next step here?
First call, like 0.
And let me show you, to be honest, I wouldn't have done what I just did. I sort of forgot where I was. I wouldn't even have written those. How did I make the 1 again? Because these were 1 apart, so I can just subtract them and make a 1, right? And to be completely honest, I would have just immediately, because the whole point of matrices is to reduce the amount of shit you got to write. So couldn't I right now just say, how would I kill the 2?
Times row 1, but
No, multiply row 1 by -2 and add it to row 2. Put the answer in row 2, right? So I don't want to have to rewrite all this shit if I'm going to immediately change it. Why not just change it right now? So if I multiply this by -2, right here. What was that, 53? So -2 plus 2 is 0. 10 plus 3 is 13. -22 minus 7 is -29. And -106 minus 14 is -120. That is the fundamental thing about matrices, using them to solve systems of equations. The thing I just did, right? Multiplying and then adding to make a 0. That is really it. That's what you're always trying to do. And if you don't want to make a 1, again, you can multiply this by -5 and this by 2, and won't they kill each other? And you'll make a 0. That's your real primary goal, is to make zeros, because you're killing that variable. It's too many freaking variables. How would I kill this guy? How would I use row 1 to kill this guy? Multiply row 1 by -5. So if I multiply it by -5, it'd be -5. I cross these out. -5, 25, -55, and -265. I think. Yeah. Oh shit. Oh shit. So all I'm doing right now is I'm doing -5 row 1 plus row 3. Put the answer in row 3. So -5 plus 5 is 0 like I want. 25 minus 1 is 24. -55 plus 11 is -44. -265 plus 59 is -206. Gross. Yes, sir.
Is that 106 on the top?
It was just there for a moment so that I could kill that 2.
And how'd you get the 106?
What did I do to kill the 2? I multiplied this by -2. All right, so 53 times -2 is -106.
Oh, okay.
Yep. And then I added it to this row so this one would die.
Okay.
Yep. I love it. So again, I'm trying to show you how to eliminate a lot of writing. If you don't mind a lot of writing, or if you're really uncomfortable with these, you can rewrite whole rows, add them together. You can do a lot more writing if you need to. So what I have right now, I got 1, -5, 11, 53, 0, 13, -29, -120. Anybody notice something about that last row? I can at least divide by 2, right? Looks like it's all I can divide by. 0, 12, -22, 103, negative. And notice, we're just lucky here. Is there any 1 here? No, but again, how can I make a 1?
row 2 minus row
Yeah, I can subtract those rows. And then keep going. If you don't see that, you can multiply this by -12, this by 13. They'll cancel, won't they? Multiply this row by -12, multiply this row by 13. The numbers will get a little big, but you got calculators. Right? I mean, you could do that. You could totally just bite into that and do it. So I want you to realize you are trying to make zeros. You have to do something to an entire row. You can't do it to one piece. That's one little mistake I see sometimes. Is somebody changes this and everything else stays the same. How the hell did that happen? You got to do it to the whole equation. to make something happen. But and who cares if the numbers get big? You got a calculator, right? It's not Math 88 anymore. I'm not going to check to make sure you can long multiply. It's crazy. I hope to God you can. But me, I would make a 1 here. Hell yeah. Right? So if I do that, if I subtract, if I do row 2 minus row 3, so row 1 stays the same for right now. I get 0 minus 0 is 0. 13 minus 12 is 1. Negative 29 minus negative 22, so plus 22 is negative 7. Negative 120 plus 103, right? I'm subtracting minus. So that'll be negative 17. That looks a hell of a lot better, right? And then I got 0, 12, negative 22, negative 103. Now I can use that 1 to kill that 5 and that 1 to kill that 12. So it's always make a 1 if you can, use the 1 to kill things around it. Go to the next column, make another 1 if you can, use that 1 to kill things around it. Move to the next one. If you can't make a 1, yeah, you probably can. You just don't realize it without making fractions. I don't want to divide by 13 again. Good Lord. Don't do that to yourself. I can tell you guys love this, but it just takes a little bit of pushing through to get it. It's not difficult computations involved. It's just a different organization that you're not used to. That's all. Okay. Anything else from Homer stuff or about matrices in general or anything?
What problem was this?
Oh, yeah, I just picked 44 out because they didn't have any ones. Yeah. Oh. Well, at least they didn't mess that up.